This is page 5 of our notes, actually page 4, and then we're going to go on to page 5. So page 4, the probability of mutually exclusive events. If it is impossible for two events to occur at the same time, the events are called mutually exclusive. So the word impossible right here. And mutually exclusive here. The probability that the two events will happen is the sum of the probabilities of each event. So here's our formula here. So the probability that A can happen or B can happen or both is by finding the probability of A and adding the probability of B. This is for mutually exclusive events because there's not going to be any overlap. Okay, here's some examples. One card is selected from a deck of cards. What is the probability that the card is a 2 or a face card? So those are two completely different things because if the card is a 2, it's not a face card. And if the card is a face card, then it's not a 2. So let's find each individual probability and then add those probabilities together. So the probability of getting a face card, we have Jack, Queen, and King in each suit, 4 different suits, so that is a total of 12 cards in our deck that are face cards. Okay, and then we want the probability of getting a 2. So the probability of getting a 2, there are 4 2s, one of each suit, in a deck of cards, so 4 out of 52 are 2s. So those are completely separate events because a face card is not a 2. There's never going to be an overlap there. We call that mutually exclusive. Okay, so that's 16, 12 plus 4, out of 52 because we have the same denominator on both of those. And then we can reduce that to 8 over 26, which reduces further into 4 over 13. So we have a 4 over 13 chance of getting either a face card or a 2. So if we want to divide that out, we would find out that that is approximately 30.8% probability of getting one or the other of those events to happen. Here's a second example. 20 ping pong balls are numbered from 1 to 20. What is the probability that the number on the ball is odd or that it is a 4? Okay, so we have our ping pong balls numbered from 1 to 20. The first probability we're looking at is odd, so the probability of it being odd would be the numbers 1, 3, 5, 7, 9, 11, etc. till we get up to 19, right? So half of those numbers are odd. So 10 of the 20 of them are odd. Then we would want to add to that the probability that we get a 4. Now the reason these are mutually exclusive events is that 4 is not an odd number, so there's no overlap here. The odd numbers and the number 4 are completely separate events. So the probability of getting a 4 from our ping pong balls numbered from 1 to 20 is one of those 20 ping pong balls. So that gives us a total of 11 out of 20, which is a 55% chance of getting either an odd number or the number 4. Okay, let's look at events that are not mutually exclusive. That means they do have overlap. We're also going to look at a sample space. Okay, the probability of the union of events. So this is where we have events that are not mutually exclusive. They have some sort of element that overlaps. If it is possible for two events to occur at the same time, the events are not mutually exclusive. Let's throw that in our blank spot here. occur at the same time. If it is possible for two events to occur at the same time, the events are not mutually exclusive. Okay. The probability that events E1 or, now the use of the words or and, it's really important to understand the difference. The word or means union, and that includes everything. The word and is just where the two things overlap. So we can talk about that in terms of a Venn diagram here in a second. The probability that events E1 or E2 will occur is equal, now I messed this up when I did these notes, so we're going to make some modifications here, is equal to the probability that E2 will occur plus the probability that E1 will occur minus the probability that E1 and E2 will occur. Okay, so the part that we are missing here is including just the probability of E1. So the probability that events E1 or E2 will occur is equal to the probability E1 will occur plus the probability, I guess we could end it right there, and then I'll show you how that fits in there. Okay, move that here. So the probability that events E1 or E2 will occur is equal to the probability that E1 will occur plus, did I lose the word plus? Plus, I'm going to take out the word 2. So the probability that events E1 or E2 will occur is equal to the probability that E1 will occur plus the probability that E2 will occur minus the probability that E1 and E2 will occur. And that's because we have to subtract out any overlap. Since they're not mutually exclusive, they could both happen at the same time. And we don't want to count those numbers twice. Example, if you roll 2 dice at the same time, determine each probability. So first thing I want to bring to your attention is this thing here, which is called a sample space. Let's say that the blue numbers represent one of our dice, and the red numbers represent our other dice, right? So if we're throwing 2 dice at the same time, we're going to get 2 different numbers, one on each die. And this is our possible sample space. This is all of the possible combinations of numbers we could get on those 2 dice. Okay, so now we're going to use the sample space to answer the question. What is the probability that the sum is 6 for a pair of odd numbers? Okay, let's start by looking at the sum is 6. So let's choose a color for that. So I'm going to look at the sum. So I want to use a little bit different notation here. So the probability that the sum equals 6. Let's look at that first. So let's circle any possibilities in our sample space where the 2 numbers add up to 6. So we have a 1 and a 5, or a 2 and a 4, or a 3 and a 3, or a 4 and a 2, or a 1 and a 5. Are there any other possibilities that would add up to 6? So how many possibilities do we have total in our sample space? We've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We have 36 possible outcomes from our 2 dice. Okay, so the possibility of getting 2 numbers on those dice that will add up to 6 is 5 out of 36. All right, next we're looking at pairs of odd numbers. So P is a pair of odd numbers. So now let's go through and circle anything that has pairs of odd numbers. So 1 and 1, 1 and 3, 1 and 5. Those all have 2, so those don't work. 3 and 1, 3 and 3, 3 and 5. Those all have 4, so none of those work. 5 and 1, 5 and 3, 5 and 5, and then those all have 6s, so none of those are a pair of odd numbers. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs of odd numbers, so 9 out of 36, right? So now here's where this part of our formula here comes in. Highlight this. We now have to subtract out the overlap. What do we mean by that? Well, did you notice that I circled some of the numbers in our sample space twice, once in green and once in purple? I should have left my highlighter here. So this one was circled twice, and this one was circled twice, and this one was circled twice because those both add up to 6, and they're a pair of odd numbers. So if we count them in the green ones, 1, 2, 3, 4, 5, we did. And we counted them in the purple ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, we did. We counted them twice. So now to make up for that, we have to subtract those back out so that they don't get counted twice. So we're going to go ahead and subtract out the probability of both the sum and the odd numbers. And as we discovered, there are 3 of those. So that is 3 of the 36. Okay, let's find our total probability now. So we have 5 36 plus 9 36 minus 3 36 gives us 14 minus 3, 11. So 11 over 36. So the probability of getting either a pair of numbers that add up to a 6 or a pair of odd numbers is 11 out of 36, which is about 30%. I don't know if it helps to understand this sample space and this particular situation shown as a pair of Venn diagrams. Since we did an assignment on that and people seem to be struggling with it, let's go ahead and fit this situation to a Venn diagram. So a Venn diagram is where we use circles to show how things overlap. So let's say one circle represents a sum of 6, and another circle represents odd numbers, so a pair of odd numbers. Maybe I should be more specific. Okay, and we had 3 that fit in both categories, right? So there were a total of 5 that added up to 6, but 3 of those were also pairs of odd numbers. So we had 2 that were a sum of 6 without also being a pair of odd numbers. So together we have 2 and 3, which is 5 pairs of numbers that add up to 6. Then we have pairs of odd numbers, and we counted 9 of those. But 3 of those were ones that also added up to 6, which is why that's in the middle. So there's 6 more over here that don't add up to 6. So that gives us our 2 plus 3 is 5 plus 6 is 11 total out of 36. Now how many numbers in our sample space did we not circle because they didn't fit in either of these categories? Well, that would have been whatever 36 minus 11 is, so 25. So out here, outside of our circles, we have 25 numbers that don't fit into either circle. So together, 2 plus 3 plus 6 plus 25 add up to our total sample space of 36. And this 3 shows us the overlap, which is why we had to subtract that out because we don't want to count it twice. And these numbers show us the total that just fit in that portion of the circle. If we would want the entire number that add up to a sum of 6, then we would add the 2 and the 3 together and get 5. If we wanted the total number of the pairs of odd numbers, we would add the 3 and 6 together and get that total of 9. I hope this makes sense.